What if I told you that that pristine, undeniable pie chart you saw in yesterday's board meeting was built on numbers that a data analyst literally just, well, made up?
Yeah, it's a terrifying thought. But I mean, it happens constantly. We just sort of assume data is perfectly objective.
Right?
But the whole process of getting it ready for that boardroom it's incredibly subjective.
Welcome to our exploration today. We're taking you, the learner, behind the scenes into the messy, honestly kind of fascinating reality of data analytics.
Exactly.
We are diving deep into the raw mechanics of data cleaning, trying to uncover the hidden human biases and mathematical rules that dictate how truth is formed. So, okay, let's unpack this, because before we can even talk about manipulating data, we have to understand the physical journey it takes just to get onto a clean spreadsheet.
Right, and that journey relies on what's called the ETL pipeline.
The ETL pipeline.
Yeah, which stands for extract, transform, and load. Basically, you extract data from a raw origin like a CSV file.
Which is just a really basic text file, right? Comma separated values.
Exactly, just raw text. So you pull it from there into an editing tool like Power Query to transform and clean it, and then finally you load it into your main spreadsheet for analysis.
Okay, so the CSV is like a muddy lake,
Sure.
and the editor is the filtration plant where we extract the dirt, and then the final spreadsheet is the clean water coming right out of our tap.
If we connect this to the bigger picture, setting up that filtration plant correctly is literally the foundation of all business intelligence. I mean, if your pipeline is flawed, your whole analysis is just toxic.
Wow.
And that transformation stage involves very specific mechanics, like telling the software to ignore junk text or promoting the first row of real data as your headers.
Oh, right, because sometimes the raw file has like weird system codes at the top.
Exactly. Or you might use delimiters, things like spaces or commas, to split up mashed up data. So if you have a single column that says, April 2nd, New York.
You can just split it, the space.
Yeah. You split it at the space to create separate date and city columns.
And the really cool part from the source material is that the connection between the editor and the final sheet goes both ways. Like, analysts can constantly go back into the filtration plant to adjust the settings if they spot an issue in the final output.
They absolutely have to do that. It's a continuous loop.
But even the best ETL pipeline can only filter the water that's actually there. So what happens when the pipe is just pumping air? Like when the data is just missing?
Well, that is where the process becomes highly analytical. You have to figure out what to do with these gaps, which we call null values.
Null values, right.
And your approach changes entirely depending on whether you are looking at numerical data, so numbers, or categorical data, like words or labels.
Okay, let's start with the numbers. If I'm looking at a spreadsheet tracking, I don't know, wine inventory, and I have a completely blank cell for the quantity sold. I mean, I can't just leave it blank, right? But I also can't just plug in a zero.
Well, context dictates everything here. If the column tracks sales revenue, an empty cell might legitimately mean $0 were made.
Oh, true. No sales, no money.
Exactly. But if your wine quantity column is blank, or worse, showing a negative number, that's a data error.
Right, because you physically cannot buy negative 2 bottles of wine.
Right, so you have to convert those impossible errors into null values first.
But wait, if I have an empty cell for inventory, and I use a technique like plugging in the mean, which is just the standard average, right?
Yes.
Or the median, like the exact middle number if you lined all the data up. Aren't I literally just making up data? How is that remotely accurate for a business?
I know, it feels incredibly counterintuitive. But dropping the row entirely is actually a last resort.
Really? Just deleting it is bad.
Yeah, it's usually only acceptable if blanks make up less than 10% of your whole data set.
Yeah.
Like if it's just missing a customer ID that you don't even need.
Oh, I see.
Because if you delete every row with a missing number, you lose all the other valuable data tied to it, like the date of the sale or the location.
So the whole transaction just vanishes.
Exactly. By filling the gap with the median, you keep the row alive without violently skewing your overall totals. It minimizes the distortion of the data set.
Okay, here's where it gets really interesting, because I can understand finding a mathematical middle ground for numbers.
Yeah.
But what do you do when the missing data is a category?
Yeah.
Like a word. You can't find the average of a word.
You really can't. So analysts often look at the mode.
The mode.
Yeah, the most frequently occurring entry in a data set. But doing that introduces a massive risk.
How so?
Think about a data set tracking demographics.
Yeah.
If you have a bunch of missing genders and you decide to fill those blanks with female, just because female happens to be the mode, you've suddenly manufactured an artificial gender bias in your metrics?
Wow. You're literally skewing reality.
This raises an important question about how data sensitivity should dictate our actions. Because imagine a marketing survey asking, "How did you hear about us?"
Oh, wow.
If an analyst replaces all the blank answers with word of mouth simply because it's the most common response,
They're generating fake success metrics.
yes, they're basically lying to the marketing department.
So what's the alternative then? You can't use the mode, but you can't leave it blank. You just label it unknown.
Marking it unknown or uncategorized is actually the safest and most brilliant move.
Really? Just admitting we don't know.
Yeah, because it forces accountability. Instead of covering up missing information with statistical duct tape, it exposes a flaw in how the company gathers information. It prompts them to fix their data collection at the source.
Okay, so we use unknown for words to avoid bias.
Oh.
But going back to those numbers for a second, how do we definitively know when to use the standard average, the mean versus the middle number, the median? Like, how do I choose?
What's fascinating here is that it all comes down to the literal physical shape of the data.
The shape.
Yeah. You have to look at the normal distribution, which is your classic bell curve.
Oh, like rolling dice.
Yeah.
If you roll 2 dice 1,000 times, you'll rarely roll a 2 or a 12.
Exactly.
But you'll roll a ton of 7, so the outcomes just kind of pile up in the middle, creating that bell shape.
And that perfectly illustrates the concept. If your data forms a flawless symmetric bell curve, a uniform normal distribution, the mean and the median are the exact same number.
So you can just use the mean to fill your gaps.
Right. But data is rarely that perfect. Usually it's what we call skewed, meaning it's asymmetrical with a long tail dragging out to one side.
Like having a few billionaires in a room full of middle-class workers, it just pulls the average way, way up.
Yes. Those extreme values pull the mean far away from the actual center. So when your data is skewed, you absolutely must use the median to find a realistic middle ground.
Okay, but calculating all this, checking for skew, handling nulls, finding medians, it sounds incredibly manual.
Yeah, it is.
Why go through all this math? Can't we just dump the raw CSV file into an AI and tell it to clean the data for us? I mean, it's 2026.
You'd think so, right? And AI tools like Gemini and Google Sheets, they are fine for very small data sets, maybe like 150 rows.
Okay.
But if you throw a massive enterprise-level data set at an AI, it will literally start to hallucinate. It will falsify numbers.
Wait, really? Aren't computers supposed to be, like, perfect at math?
Well, large language models aren't calculators. They are prediction engines designed to guess the next logical word in a sequence.
Right, they're just guessing.
Exactly. So when you feed them 500,000 rows of data, they lose the context of the numbers. They start guessing patterns that don't exist, creating completely fabricated data points.
So what does this all mean? It sounds like relying on AI to clean massive data sets is like hiring a highly confident intern.
That's a great way to put it.
Like, they are great for organizing a single filing cabinet, but you absolutely wouldn't trust them to manage a 500,000 file corporate archive without checking their math.
You simply can't set it and forget it. For scaling up data cleaning, human oversight is mandatory. You have to use advanced programmatic tools like Python, guided by a human who actually understands the context of the information.
We've covered a massive amount of ground today. We moved from the mechanical plumbing of the ETL pipeline, extracting and transforming our data.
Yeah.
We navigated the pitfalls of missing values, discovering how easily the mode can inject bias into our categories. We learned how the bell curve dictates our math, and we finally saw why AI just can't replace a human analyst quite yet.
It completely reframes how you consume information, doesn't it?
It really does. And for you, the learner, whether you are analyzing a market trend or just looking at an infographic on the news, remember that the data you are seeing has been shaped and altered by human hands. It's a painting, not a photograph.
Which leaves us with a totally new dilemma to consider. Yeah. If data analysts hold this much invisible power to shape reality with their assumptions and transformations, should they be required to follow a sworn ethical code or hold professional licenses, just like doctors or civil engineers?
Wow. Something to mull over the next time someone tells you the numbers speak for themselves. Keep questioning the data.